Hello everyone, welcome to today's lecture. In today's class, we will practice some more questions based on area bounded by the curves. In the last session, we had practiced till question number 21. Now in this session, we will start from question number 22 and we will discuss till question number 28. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iita.ac.in and we shall remove the images. So let's move to question number 22, which says the area bounded between the parabola x square is equal to y by 4 and x square is equal to 9y and the straight line y is equal to 2 is. So see, the hint of this question is what we will do. First, we will draw the graph of the two parabola, which is x square is equal to y by 4 and x square is equal to 9y, right? And we will try to see the points of intersection. I think these parabola will intersect at only one point, that is 0, 0, right? And we will draw the line y equal to 2. And actually, we have to basically find the area that comes under these two parabola and below the line, right? Clear? So in this way, you try to approach this question. After 10 seconds, you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part. See, as the area between the parabola x square is equal to y by 4 and x square is equal to 9y, see, the graph of these two parabolas are as follows. This is y equal to 4x square and y equal to 1 by 9x square. And a straight line y equal to 2, right? Therefore, required area will be, see, these graphs are basically symmetric, right? And area under these graphs will also be symmetric, right? Area under these graphs will also be symmetric, got it? Therefore, required area is 2 times integration of 0 to 2, 3 root y minus root y by 2 dy, clear? Therefore, integration of 2 times 0 to 2, 5 by 2 root y dy. After solving this, you will get 5 by 2 root y. Clear? 5 by 2 root y dy, which is equal to 5 times y to the power 3 by 2 upon 3 by 2, and limit is from 0 to 2. Therefore, after putting the limit, we will get area as 10 by 3 into 2 to the power 3 by 2 minus 0, which is equal to 20 root 2 by 3, which is equal to 20 root 2 by 3. Clear? Therefore, option C is the right choice. Got it? Option C is the right choice. Now, let's move to the next question. Question number 23, which says that the area enclosed by the curves y is equal to x cube and y equal to root x is. The area enclosed by the curves y equal to x cube and y equal to root x is. So, the hint of this question is what we have to do. We have to basically draw the graph of two curves, right? Y equal to x cube and y equal to root x. So, these graphs are easy to draw, right? These graphs are easy to draw. And after drawing the graph, we will find the point of intersection between these two curves. And we will try to integrate the area between the points of intersection, right? And try to find the area enclosed between the curve, right? We'll integrate the function from the starting point of the intersection and ending point of the intersection, right? So you have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Now, this is the graph of the curve. Clearly, the intersection of two curves y equal to x cube and y equal to root x are given by x equal to 0 and x equal to 1, right? By x equal to 0 and x equal to 1, clear? So these are points of intersection. You can see, therefore area will be points of intersection 0 and 1, right? Therefore area will be 0 to 1. We are doing intersect, we are doing integration of y dx, right? So y is equal to x cube and root x, right? Therefore, area of modulus of 0 to 1 x cube minus root x dx, which is equal to x to the power 4 by 4 minus 2 x to the power 3 by 2 upon 3. And limit is from 0 to 1, right? Therefore, after putting the limit, area is basically 1 by 4 minus 2 by 3, which is equal to 5 by 12 square unit, right? 5 by 12 square unit. Got it? So I think option C is the right choice. 5 by 12 square unit. Got it? Now let's move to the next question, question number 24, which says the area in square units of the region xy, where y square is greater than equal to 2x and x square plus y square is smaller than equal to 4x, and x greater than equal to 0, y greater than equal to 0 is. So again, the hint of this question is we have to basically find the area outside this region and outside this parabola and inside this circle, right? Outside this parabola and inside this circle. So we will first find the points of intersection of this parabola and this circle, right? And we'll try to integrate and find the area enclosed between them, right? Also, prior to integration, we'll first check whether the figure is symmetric or not, right? If figure is symmetric, then we can integrate the area, integrate the common area, and taking the twice, multiplying it by 2, right? Clear? So in this way, you try to approach this question. You have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. As we have x square plus y square smaller than equal to 4x and y square greater than equal to 2x. So to find point of intersection, substitute y square is equal to 2x in x square plus y square equal to 4x. Now x square plus y square is equal to 4x. This implies x square plus 2x is equal to 4x, right? X square plus 2x is equal to 4x. Clear? And now after solving, we will get x square minus 2x equal to 0. Therefore, x into x minus 2 equal to 0. So either x equal to 0 or x equal to 2. Therefore, y equal to 0 or y equal to 2. Clear? Y equal to 0 or y equal to 2. Got it? These are points of intersection 0, 2, x0, x2 and y0, y2. Clear? So required area will be integration of 0 to 2 y1 minus y2. Right? Integration of 0 to 2 y1 minus y2 dx. And integration of 0 to area of circle. Integration of 0 to will do integration of 0 to 2 area of circle. Integration of 0 to 2 area of this circle minus integration of 0 to 2 area of parabola, right? Integration of this circle minus integration of 0 to 2 integration of circle minus 0 to 2 integration of parabola. Got it? Which will be the area of shaded portion. Therefore, it will be equal to pi r square by 4 minus integration of 0 to 2 area of circle from 0 to 2 is basically area of quarter circle, right? Area of quarter circle having radius 2 unit. Here, so area will be pi r square by 4 minus 0 to 2 root x, 0 to 2 root 2 x to the power 1 by 2 dx, right? X to the power 1 by 2 dx. Therefore, it will be equal to pi into 4 upon 4 minus root 2. After putting the limit, we will get root 2 into 2 by 3 x to the power 3 by 2, 0 to 2. And after putting the limit, we will get area as pi minus 8 by 3 is the right answer. Okay, pi minus 8 by 3 will be the right answer. Got it? So option B is the right choice, pi minus 8 by 3. Got it? Now let's move to the next question, question number 25, which says the area of the region described by A is equal to xy such that x square plus y square is smaller than equal to 1 and y square is smaller than equal to 1 minus x is. So see, in this figure, in this question again, the hint is we have to basically find area enclosed between these two regions, right? So first we will try to draw the graph, and after that we will try to find the points of intersection between these curves, and we will integrate the area between their points of intersection. Clear? So in this way, you can try to approach this question. You have 10 seconds to solve or think about this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part C. As area is given as xy such that x square plus y square less than equal to 0 that is area inside this circle having radius 1 unit. And this parabola y square is smaller than or equal to 1 minus x. So this parabola is this one, right? This one. So we have to basically find area enclosed between these two curves, that is area of this shaded region, right? Now, this circle have radius 1 unit, therefore this point will be 1, 0 and minus 1, 0. Clear? Therefore required area will be 1 by 2 pi r square plus 1 by 2 pi r square. That is the area of this region, half circle, 1 by 2 pi r square plus 2 times integration of 0 to 1, 2 times integration of 0 to 1 minus y square dy, right? 2 times integration of 0 to 1 minus y square dy. Therefore, it will be equal to 1 by 2 pi, 1 square, plus 2 times y minus y cube by 3 from 0 to 1. After putting the limits, we will get answer as pi by 2 plus 4 by 3, pi by 2 plus 4 by 3, right? Therefore, option A is the right choice, pi by 2 plus 4 by 3. Got it? Now, let's move to the next question, question mark 26, which says that the parabola y square is equal to 2x divides the circle x square plus y square is equal to 8 into 2 parts, right? Then the ratio of the areas of these parts is. So see, the hint of this question is we will first try to draw this parabola and this circle, right? And we'll see that this parabola is dividing this two circles to 2 parts, right? And we'll try to find the points of intersection, and by integrating we'll try to find the areas of each part, right? Areas of each part, and after that we will take the ratio. Okay. So in this way you can try to approach this question. You have 10 seconds to solve this question. After 10 seconds we will discuss the solution. Okay, let's move to the solution part. See, this is the figure in which this x square plus y square equal to 8 is the circle, and y square equal to 2x is the parabola, right? So let the area of the smaller part be A1, and that of bigger part is A2, right? And we have to find basically A1 upon A2. Got it? So a smaller part is basically this one. And larger part is the curve apart from this curve, right? Therefore, the point B is a point of intersection that is lying in the first quadrant of the given parabola and circle, whose coordinates can be obtained by solving the two equations, y square equal to 2x and x square plus y square equal to 8, right? Therefore, after solving these two curves, you will get x square plus 2x equal to 8. This implies x minus 2 into x plus 4 is equal to 0. Therefore, we will get x equal to 2 and minus 4. X equal to minus 4 is not possible, as both the points of intersection have same positive x coordinate, right? Thus, point C will be equal to 2, 0. That is, this point C will be equal to coordinate of this point C is equal to 2, 0, right? Now A1 is basically 2 times area of OBCO, right? 2 times area of OBCO plus area of 2 times area of OBCO plus area of CBAC, right? Clear? That is 2 times area of this region. Got it? So how can we find area of OBCO? So 2 times integration of 0 to 2 y1 dx plus 2 to 2 root 2. First we are integrating from 0 to 2, after 0 to 2, then after 2 to 2 root 2, right? Therefore 2 times integration of 0 to 2 y1 dx plus 2 to 2 root 2 y2 dx, where y1 and y2 are respectively the values of y from equations of the parabola and that of the circle, right? Therefore A1 is equal to 2 times integration of 0 to 2 root over 2x dx plus integration of 2 to 2 root over 8 minus x square dx. Therefore A1 is equal to 2 times root 2 plus 2 by 3 x to the power 3 by 2, and limit is from 0 to 2 plus x by 2 because we have to apply the integration of this one root over 8 minus x 8 plus minus x square, which is equal to 2x by 2 root over 8 minus x square plus 8 by 2 sine inverse x by 2 root 2, and limit is from 2 to 2 root 2, right? After putting the limit, you will get 16 by 3 plus 2 times 2 pi minus 2 pi minus 2 plus 4 into pi by 4, and after solving you will get answer as 4 by 3 plus 2 pi square units, right? Therefore, option B is the right choice. Option B is after, and we can solve further. We can solve for clearly area of the circle will be pi r square, which is basically pi into 2 root 2 square, which is 8 pi square unit. And now A2 is basically whole area is basically 8 pi. Therefore, A2 will be 8 pi minus A1, which is 6 pi minus 4 by 3. Therefore, required area will be A1 upon A2. Required area will be A1 upon A2, which is 4 plus 3 plus 2 pi upon 6 pi minus 4 by 3, which after simplification you will get 2 plus 3 pi upon 9 pi minus 2. Therefore, option B is the right choice. Got it? Option B is the right choice. Now, let's move to the next question, question number 27, which says that the area bounded by the curve y is equal to 2 minus mod 2 minus x and mod x into y is equal to 3 is. So, what can we do? The hint of this question, we will try to draw the graph of the two figures, right? And after drawing the graph, we will try to see the points of intersection, and by the geometrical interpretation, we might calculate the area, right? And we can also use the integration form. Okay. So in which way you can try to solve this question? You have 10 seconds to solve this question. After 10 seconds, we will discuss the solution. Okay, let's move to the solution part. See, first see y is equal to 2 minus mod 2 minus x. Therefore, it can be written as a piecewise function. Therefore, y is equal to x when x is less than 2. And after solving this, we will get 4 minus x when x is greater than equal to 2. And the second curve is y is equal to 3 upon mod x, which we will get y is equal to minus 3 upon x when x is less than 0 and 3 upon x when x is greater than 0. Clear? Now we can draw the graph of the two figures. Clear? And draw the points of intersection, right? Therefore, x is equal to 3 by x. This implies x is equal to root 3. And 4 minus, if we equate these two equations, we will get 4 minus x is equal to 3 by x, which is equal to x is equal to 3, which will get x equal to 3. Therefore, required area will be integration of root 3 to 2, integration of root 3, this is root 3 to 2, x minus 3 by x dx plus 2 to 3, 4 minus x minus 3 by x dx, which after integration you will get 4 minus 3 log 3 upon 2 is the right answer. 4 minus 3 log 3 upon 2 is the right answer. Okay. So I think option C is the right choice. Okay. Option C is the right choice. Got it? Now let's move to the next question. Question number 28, which says the area bounded by the curve y equal to mod x minus 1 and y is equal to minus of mod x plus 1 is. Again, the hint of this question is what you can do. First, you will try to draw the graphs of these two curves, and you might use geometrical interpretation to calculate the area, or you can first break these curves into a piecewise function and try to integrate between the intersection parts. Okay. In this way, you can try to approach this question. You have 10 seconds to solve this question. After 10 seconds, you will discuss the solution. Okay, let's move to the solution part. C. The region is clearly square with vertices at the point 1, 0, 0, 1, minus 1, 0, and 0, minus 1. So these are the basically region enclosed between these whole curves. Therefore, it is basically square, right? And area is basically root 2, because this side is 1 unit, this side is 1 unit. So area this side will be root 2, right? So it is area of a square having side root 2. Therefore, its area is root 2 into root 2. That is 2 square unit, right? 2 square unit. Therefore, option B is the right choice. 2 square unit. Got it? 2 square unit. Got it? So in this way, we have discussed a lot of different types of questions between area bounded by the curves. Okay, so hope you understood the concepts behind this question and hope you liked the lecture. Okay, thank you so much.